So we got the active learning questions for exam 3. I would recommend just printing that off and try to find the answer to each of those different questions. And there's quite a few. There's like 40, 41 questions there because that's how many questions are on the exam. There is one question, number 40, I wanted to point out on here because that's what we call an arterial blood gas interpretation question. Arterial blood gas interpretation. So that's chapter 8 in your book. And it appears to me, number 41 is also about acid base. But it appears to me that there's not a ton of questions about chapter 8. And so I would encourage you to skim that chapter, but maybe not spend your whole life trying to understand it. It's very complicated, very difficult to understand. Acid-base balances, chapter 8. What does the nurse really need to know? The bedside nurse or the bedside healthcare provider about acid-base balance? Not a lot. But you will be tested on ABGs all the time in nursing school and even after. For some reason, that's something that test writers love to put on exams. ABG interpretation. So do skim that chapter, but don't spend a whole ton of time, because I was thinking the other day, how many times in my career has a patient's outcome been impacted by their arterial blood gases? I can only think of one patient of the tens of thousands of patients that I've taken care of where the ABGs actually made a difference. The only patients, in my opinion, that we even need to draw arterial blood gases. ABGs are a very painful blood draw. Has anyone ever had ABGs drawn? Basically, it's a big old sharp needle, but instead of going into a vein, they jam it in an artery. Very painful. It's usually your radial artery in your wrist. If we can't get it there, we'll find a different artery. It's a painful lab draw. And the only patients that, in my opinion, actually need ABGs are your overdose patients. So in mental health nursing, which I do teach also, ABGs are useful, specifically because we're looking at the anion gap in those patients. But your routine COPD, respiratory arrest, stopped breathing, overdosed on heroin, can't breathe, had pneumonia, can't breathe, got the COVID, oh no, can't breathe. Do we really need to draw ABGs on those patients? Not really. It's not going to change a single thing that we do. And there's a big reason for that now. The invention of a device, a technological advancement in the care of the critically ill patient called the end-tidal CO2 monitor. The end-tidal CO2. Fascinating little device. We can make it so that it's built into an oxygen nasal cannula. Put somebody on an oxygen nasal cannula that has end-tidal CO2 built into it, and we can measure their carbon dioxide level with every single breath that they breathe. That number, their CO2 level, correlates exactly, precisely with the arterial blood gases. So we don't need to draw blood work to find out a person's CO2 level anymore. We just put an end-tidal CO2 monitor on. We also don't have to draw blood gases to find out somebody's oxygen level. We've been using an oxygen saturation finger device for 20 or 30 years. We've been using end-tidal CO2 for probably 10 or 15 years. Because of those two devices, they're cheap. We can do them at the bedside. I don't see any reason to ever draw ABGs on a person. This is just my opinion. So don't go around saying this to your doctors when they order ABGs. My opinion, the only reason we order ABGs is because insurance still pays for it. And we're going to milk as much money out of insurance as we can. So I was in clinicals Monday and Tuesday, critical care this week, and almost every single one of our patients was getting arterial blood gases drawn every 2 or 4 hours. Very painful needle stick every 2 or 4 hours. Did it need to be done? No, absolutely not, actually. Because all of those patients, every single one of them, we were concerned about their acid-base balance, which is that whole chapter 8 in the book. But the only number we were watching was their CO2 level, which we could have obtained by putting a nasal cannula on them with an end-tidal CO2 monitor. Anyway, I don't know if that made any sense. Do skim that chapter, the acid-base balance chapter, because there's always going to be test questions from here on out until you graduate. But the chapter that I would spend the most time reading in this pulmonary section, so we got chapter 8. I'm going to go out to the modules here. We last week talked about section 5, which is all the cardiac stuff. The way I would rate those chapters is chapter 15 most important, 16 second most, 17 third most important, chapter 18 and 19 not really important. That's the arterial disorders, the ischemic heart disease, and the heart failure chapter. Those would be really good chapters to read. You will take care of those patients every single day of your career. Under section 6, the pulmonary respiratory system, the assigned reading includes chapter 8, acid-base imbalance. That's the one I was just ranting about. We love to write test questions based on this content, but it's not very useful for the bedside nurse. I would say 99% of bedside nurses do not know how to interpret arterial blood gases, and there's nothing wrong with that. No patient has ever suffered because they did not know how to interpret ABGs. It's not a very useful tool. The most bang for your buck chapter is going to be this chapter 20, respiratory inflammation and infection. That's a great chapter. I would read it not once, but twice. Respiratory inflammation and infection. Chapter 20. Skim chapter 8, read chapter 20, skim chapter 21. Chapter 21, in my opinion, presents the content in a very confusing way. That doesn't make any sense to me. Restrictive versus obstructive pulmonary disorders. What are they even talking about? It's very confusing. They do have good sections about asthma, COPD, emphysema. So do try to know the differences between those things. But spend most of your time in chapter 20. And then look at the study guide as far as what exactly you need to know from chapter 21. There's a little few pages in chapter 40 about lung cancer. That would be useful to read because that is probably the leading cause of death by cancer. And we had 5 patients on Tuesday. Every single one was a respiratory problem. 4 of them were what we call obesity hypoventilation syndrome, just somebody that's so heavy that they aren't moving a lot of air. But we had one patient of those 5 that was just a true lung cancer patient. So we do see it. We take care of lung cancer. Know that the leading cause of lung cancer, smoking. In the book, they'll talk about a couple of things like mesothelioma or asbestos. There's 2 gases or 2 substances in your home that we worry about. 3 really. Carbon monoxide is one. We saw that in Texas this last week, carbon monoxide poisoning. Because in Texas, the power grid went down. Everybody was freezing to death. So they tried to figure out how to stay warm. They're lighting fires inside their houses or using their stove as a space heater. Carbon monoxide poisoning. And every ER in the state of Texas last week was inundated with carbon monoxide poisoning. Very lethal. But another potential problem in your home is asbestos. They passed laws about 20 years ago. You can't use that. I know that in our house, we just bought a house this last year, and it's about a 60-year-old home, and it has asbestos in it. So the problem with asbestos is that if you disrupt it, it's like insulation. In my house, it's insulation around some of the duct work, and it's white. The problem is if you chop it out of there or break into it, it releases these ultra fine particles into the air. If you breathe those in, you get mesothelioma, asbestos. The other potential problem here in Nebraska and Iowa is radon gas, which can seep into your basement. And the state of Iowa and Nebraska have some of the world's highest amounts of radon gas. What that is actually radioactive material in the soil outside of your basement wall. This radioactive material is slowly degrading and emitting what's called radon gas. So we got radon gas potentially in your home. We've got asbestos potentially in your home. And we've got carbon monoxide potentially in your home, especially in the winter. Carbon monoxide, I would encourage you to purchase a carbon monoxide detector if you don't have one. It's a city building code that you have to have a carbon monoxide detector on every level of your house. It's not a bad way to die. You basically just fall asleep and then don't wake up. So if you had to choose a way to go, sounds reasonable. But if you don't want to die early, buy yourself a carbon monoxide detector, especially for the winter months. The other 2, radon gas, leading cause of lung cancer, and asbestos, leading cause of lung cancer. Here's the interesting little conspiracy, though, on both of those 2 substances. The conspiracy is all of the original research on asbestos and radon gas did not take out of the equation cigarette smoking, because all of these studies were done like in the 1950s, 1960s, and everybody smoked. Every single person in every asbestos study was also a chain smoker. So now today, in today's world where a lot of people don't smoke, there's a conspiracy afoot, and people that build homes are the ones that are interested in this. Does asbestos really cause cancer? Does radon gas really cause lung cancer? We're not sure. There's no research ever done that didn't use a patient who was smoking 2 or 3 packs a day, because that was the norm in the 1960s when the research was done. Just kind of interesting. The idea with radon gas is we think the gas itself doesn't really bother you until it's combined with cigarette smoke in the air. And the radioactive particle then combines with the cigarette smoke, and then you inhale it. Lung cancer waiting to happen. Anyway, something to think about. So that's that lung cancer bit. Chapter 40, do read that. I know there's at least 1 or 2 questions on the exam specifically about aging and the respiratory system, which is out in chapter 45. So do go look at chapter 45, because they kind of put 1 or 2 questions on each exam about aging, the respiratory system specifically. ARDS is out in chapter 46 of the book. Do look at that. And the reason I would encourage you to read those, it's only 2 pages, page 1165, 1167, ARDS. That will help explain how people die from the COVID. So I would read the ARDS chapter and try to understand as much about that as you can. Anyway, any questions as to where we are at and what to study for the exam? Today we're going to talk briefly about chapter 8 and then dig into chapter 20, and then we'll be done for today. Do you guys on Zoom have any questions at all?
No questions.
Same here, nothing.
Nope, very good. All right then, let's just pull up the PowerPoint. Arterial blood gas or acid-base imbalance. Again, my opinion on this chapter, it's fun to study. I've always enjoyed trying to understand arterial blood gases, but I'm a nerd and I love pathophysiology, and I can't think of one single patient where the ABGs made a difference on the care of that patient. One time, though, I can tell you a story. One time, the ABGs did make a profound difference. We had a patient come into the ER. She was an elderly grandma, not super old. She was in her 60s, like 65, but she was a grandma. But she was also mentally handicapped, fairly disabled in the sense that she had to have a caregiver. Her caregiver was her daughter. She lived with her daughter, and she came into the ER completely unresponsive. And her blood pressure was tanking. She was starting to crump. That's what we call it when your blood pressure gets really low. She was crumping. She was crashing. She was tanking. Blood pressure was low. It was like 68/28 when she got to me in the ER. That's weird. Unresponsive. So we had to intubate to protect her airway, put her on the ventilator. And she had one vital sign that did not make any sense. And what it was her body temperature. We took her temperature with the little tympanic thermometer, and it was super low. It was like 94 degrees. But you can't ever really trust those darn tympanic thermometers. So we checked it with a couple different thermometers. It was still really low. And so the doctor asked us to do what's considered the gold standard of core body temperature, which is a rectal temp. And what we actually have at the hospital is a couple different ways to do a rectal temp. But if we're really concerned about hypothermia, where somebody has just gotten way too cold, we will put in what's called a rectal probe. And it has electronics built into it that we can plug into our monitor up on the wall. So the heart monitor now is showing a continuous core body temperature. And she was really cold, like 90 degrees, not really even compatible with life. Hypothermia by definition, except it wasn't winter time. The clinical picture made no sense. Why was she unresponsive? Why was her blood pressure super low? And why was her body temperature so cold? Weird. We drew arterial blood gases. We were looking to see if she had some lung problem that we weren't aware of. But her ABGs looked pretty good, except for one thing. She had profound anion gap acidosis, which no nurse knows what that is, by the way. Nurses don't look at ABGs and like, oh, an anion gap acidosis. So don't let the book fool you. The book will lead you to believe that that's something you have to know. No nurse knows that. But the lab had written it right on the lab report, anion gap acidosis. Since the lab had written that, we're like, oh crap. And the doctor's like, oh crap, yeah, sure enough, anion gap acidosis. Still no idea what's wrong with her. She was stable on the vent. We had to start some blood pressure meds, some vasopressors to get her blood pressure back up. And then I shipped her up to the ICU. One of my best friends was the nurse that took over in the ICU. And he spent the next 12 hours trying to keep her alive on the one hand, but also researching causes of anion gap acidosis. And it took him his entire shift until he finally figured out that grandma must have overdosed on something. She must have overdosed on something, which didn't make any sense because the family kept all the pill bottles locked up. So he called the daughter in the middle of the night and specifically asked the daughter if she could look around and see if there was any opened pill bottles. And sure enough, as it turned out, the daughter was a type 2 diabetic. And she got medication in 90-day supplies through the mail. And she didn't realize that her mom had answered the door, got the mail, opened the box, found the pills, and she thought they were candy. She thought that her daughter's metformin was candy. And so in that one case, the use of arterial blood gases and this anion gap acidosis led us down this investigation, and we finally figured out what had happened. A profound anion gap acidosis from a drug overdose. It was an unintentional drug overdose. Anyway, so that's this chapter, chapter 8, acid-base imbalances. The other patient that you will see acid-base imbalances a lot is your diabetic ketoacidosis patient. So if you have a kid, maybe a 10-year-old, 11-year-old kid who develops type 1 diabetes, that is a very common scenario where we do draw ABGs to figure out just how acidotic that kid is. The arterial blood gases are very helpful in the management of diabetic ketoacidosis, DKA, which is how every kid who's ever diagnosed with type 1 diabetes is diagnosed. We find out that he has diabetes when he goes into DKA, presents to the ER profoundly ill on his deathbed. If we don't get that DKA fixed, he's going to die. So acid-base imbalances, talk about that. Do memorize the normal blood pH. There's a few numbers to memorize in this chapter that will haunt you on exams the rest of your career. What is a normal blood pH? 7.35 to 7.45. This is how much acid, how acidic is your blood. It's a little confusing of a number because it works backwards. The lower your pH, the more acidic you are. So if you get a pH that drops down to about 7.00, that's almost incompatible with life. That's so profoundly acidotic. If you drop to 6.9, the doctor is going to be thinking about stopping life-saving measures. If you're so acidic that you're down below 7, the doctor's making some phone calls to your family. You know what? Your mom's not going to make it. 6.9, incompatible with life. The one patient that that's not true of, though, is your kids with DKA. They can get profoundly acidotic and do fine. We just have to recognize that and fix those new onset diabetes kids right away. But if this is an elderly person with pneumonia and other serious health problems, blood pH down around 7, not compatible with life, you're extremely acidotic. Above 7.45 means alkalotic. Alkalotic. We don't see that very often. It's almost always acidosis that is the problem. A low blood pH. I'm going to skip a few of these slides. This equation, I've stared at this for the last 25 years, and I still can't say that it has ever changed how I take care of a patient. It's basically the way that your body regulates acids and bases and tries to keep you within that 7.35 to 7.45 range. CO2, which is that first part of the equation at the top, carbon dioxide, that's what you exhale. When you exhale CO2, you are blowing off an acid. CO2 is an acid. The other thing to know on this equation that might be helpful is H. The H there is hydrogen. At the very bottom of this slide, it says hydrogen is a strong acid. Hydrogen is a strong acid. Where do you suppose, if we were to guess, where do you suppose most of the acid in your body is? Where is most of the hydrogen? In your stomach. Is that what you said? I can't remember. Yeah. GI says most of the acid in your body is actually just sitting right there in your stomach because it's got to digest your food. And the acid in your stomach is very strong. I remember watching a reality TV show when I was a kid where this dude ate an entire bicycle over the course of several months. He would chop it up into little tiny pieces that he could actually swallow, and he ate a bicycle. The acid in your stomach is so strong, it can actually eat through metal. It can dissolve a nail. The hydrogen, it's mostly in your stomach. I tell you that because that will help you down the road with some exam questions. Because if somebody is puking their brains out, barfing, for whatever reason, just projectile vomiting all the time, maybe they went on a Carnival cruise ship, caught a Norwalk virus, and now they've got gastroenteritis, and they're just puking their brains out. When you vomit, you are getting rid of acid because most of the hydrogen is in your stomach. So anything that causes you to empty your stomach out causes you to lose acid. And those patients present with a metabolic alkalosis, is the big fancy word for that. It means if we go back to that slide with the pH, the normal pH, if you are alkalotic, your pH is greater than 7.45. Any questions about that? Carbonic. I would say you could spend the rest of your career trying to understand this one slide, unless you have a degree in chemistry. Does anybody have a degree in chemistry? If you're like a biochem major, then this probably makes perfect sense to you. Most nurses have no idea what this is really talking about. It is important to know, though, that the lungs and the kidneys are the two organs that regulate blood pH. Your lungs do this by blowing off CO2, which is an acid. And they can regulate blood pH within minutes. Your lungs register within minutes if you are acidotic, and they will cause you to start breathing faster and breathing more deeply to blow off CO2. Your kidneys also help regulate the acid-base balance, but they do it over the course of 2 or 3 days. 2 or 3 days. The kidneys can decide to pee out more of the hydrogen, more acid, and help regulate your acid-base balance. So your kidneys do compensate, but it takes a couple days. It's not very fast. Lungs, very fast. The lungs can respond within minutes. So here's a nice picture from the book that sort of explains that. Your lungs blow off CO2. Your kidneys pee out hydrogen. The opposite of hydrogen is called bicarbonate, and that's the main base or alkalotic force in your body, bicarb. You could try this at home if you want. You probably have a box in your kitchen of HCO3. Does anybody bake foods? Baking soda. That's all that is. Sodium bicarbonate. It's a base. Little old ladies back in the day for heartburn would always put a tablespoon of baking soda in a glass of water, and it actually simply neutralizes the hydrogen in their stomach. So it works great for heartburn. But your kidneys can pee both of those out. They could pee the acid out, or they could pee the base out, the hydrogen or the bicarb. So I skipped a few slides. I would encourage you to memorize every single number on this slide. For this exam coming up, looks like just one question, but you will have this exact content. If you're in nursing school, you will have this exam question in med-surg nursing, and then again in advanced med-surg nursing. My students in the advanced med-surg, which is the very last class you have to take, they had a whole 10-question quiz last week on ABGs. And so they had to have all these numbers memorized. So I'd encourage you to start memorizing those numbers now. It will help you down the road. It's easy for me to remember CO2. The normal is 35 to 45. Well, that's very similar to the normal pH, 7.35 to 7.45. The normal oxygen in your ABGs is 90 to 100. And then the HCO3, the bicarb, that was always hard for me to memorize, 22 to 26. It's not a nice, satisfactory, well-rounded number. 22 to 26 is the normal bicarb. Remember, CO2 is an acid. Bicarb is a base, the exact opposite. Do know the normal saturation, the O2 sats. The normal is 95 to 100. I've got a couple different fitness trackers. This one is a Fitbit Sense, and it has an O2 sat monitor built into it, which is why I bought it. When the COVID first hit back in February, March of last year, there was a worldwide shortage of oxygen saturation monitors. You couldn't buy one because everybody knew that's a great way to tell if you have the COVID, your O2 sats. If your O2 sats drop less than 90, well, your lungs are taking a hit. one of the ICU nurses on the COVID unit at Bryan East, she said that when she had the coronavirus, which she got at work, she's young, 21 or 22 years old, ICU nurse. But she said for about a week, her SATs were 87%, quite a bit below 90. It was very concerning. Any questions about this slide here? It will always be something you'll need to know. Acidosis is when your blood pH is less than 7.35. Alkalosis is when your blood pH greater than 7.45. If you come in with either acidosis or alkalosis, we then want to figure out what's causing your problem. It's either respiratory or metabolic. Respiratory means you've got problems with your lungs. Problems with your lungs. Metabolic, everything else. Everything else. Could be kidney problems, could be septic shock, it could be anything. Could be diabetic ketoacidosis. I'll go back one slide. To name arterial blood gases, to name them or interpret them, the very first numbers to look at is the blood pH. If the blood pH is less than 7.35, we have acidosis. So for your quiz in a year or two, for your ABG quiz, you would write down acidosis. If the pH was greater than 7.45, you would write alkalosis. And then the next name for your ABGs is either going to be respiratory or metabolic. So we have either respiratory acidosis or we have metabolic acidosis. We have either respiratory alkalosis or metabolic alkalosis. But the pH tells us if it's acidosis or alkalosis. The CO2, the very next number, tells us if it's respiratory or not. For arterial blood gas type questions, you really, to get the questions right, you really only have to look at those two numbers, the pH and the CO2. Because if the CO2 is normal, it's not respiratory. Then you only have one other choice, metabolic. That makes sense? I don't know if that makes any sense. So we look at whether it's respiratory coming from the lungs or metabolic coming from everything else. If it's respiratory acidosis, our carbon dioxide is sky high. Respiratory acidosis, our carbon dioxide is sky high because carbon dioxide is an acid. So I'll go back a couple slides. This is a patient we took care of on Monday. She came into the ER on Sunday, not breathing so well. She had 5 different diagnoses of different lung problems. She had all of them. She had obstructive sleep apnea. She had obesity, hypoventilation syndrome. She had COPD. She had asthma. She had all these different lung problems. But when she came in, she was profoundly acidotic. Her blood pH was 7.1. So lower means acidotic. Her blood pH was less than 7.35. So she came into the ER Sunday afternoon, blood pH 7.1, acidosis. For test-taking purposes, you then have to decide, is this acidosis respiratory or is it metabolic? If somebody has 5 lung problems, you really don't even need to look at the rest of the numbers. You already know. Well, let's see. She's a COPDer. She has obstructive sleep apnea, obesity, hypoventilation syndrome, ARDS, asthma, chronic bronchitis. She has all of them. You really don't even need to look at the rest of the numbers to get the test question right. You know it's respiratory. She's got lung problems. We did draw ABGs on her, and her CO2 was 100. So her pH was low, acidosis, and sure enough, her CO2 was causing it. She had way too much acid in the form of CO2. She wasn't exhaling very well. She wasn't blowing off CO2 very well, not exhaling. How do we fix that? If you're not exhaling well, we call that ventilating, not ventilating well. What's a simple fix? Well, in the hospital, we call respiratory. The respiratory therapists, they know the answer, and that's exactly what they did. The ER called respiratory, said, hey, her CO2 is 100. Interesting thing about CO2 is it's a potent narcotic. So as your CO2 climbs, you get more sleepy. And once it gets up to about 100, you're no longer responsive. She's completely unresponsive. Respiratory therapists like, oh, that's an easy fix. I'm going to put this BiPAP mask on her, what we call non-invasive ventilation. This BiPAP mask on her, hook her up to a machine that blows all this air and causes her to exhale more deeply. She breathes in more deeply, she exhales more deeply. Half an hour later, we recheck her CO2 and it's almost normal. And she's wide awake. Says, I feel great. Can I take this mask off now? And we're like, no, don't do it, don't do it. She takes the mask off, and within half an hour, she's unresponsive again because her CO2 skyrocketed. So we put the mask back on, CO2 comes down, her blood pH gets normalized, she wakes up, feels great. It's really that dramatic. With the respiratory acidosis, CO2 is high because it's an acid, so that makes the blood pH get low. The question here in Lincoln is, what's a good preventative measure for that? Her CO2 gets too high, she becomes unresponsive, she lands in the ER. That's $1 million question, and that's exactly what we spent our whole time in clinicals dealing with, because the antidote, the answer is very simple. She just needs to wear her BiPAP mask, but she doesn't want to. So she goes home and she gets mad at the dumb machine. She refuses to put it on. She lives alone by herself. The mask is not very comfortable. It's blowing all this air in your face. So she takes it off, and then she lands in the ER. And this was her 12th admission to the hospital this year for this exact problem. And the doctor went in and talked to her. Hey, you're going to have to make a decision. Either wear your mask or you need to choose hospice, because you're either going to die because she refused to wear a mask. So it's kind of an ethical dilemma is what we ended up having, is because the only thing that would fix her, she didn't want to have to do. So the doctor, I didn't think it was very nice, but he basically threatened her with a trach. So we're either going to trach you or you need to choose how you want to live your last days. The idea being, you go home after this stay, take your mask off, leave it off for too long. Next time you come in, we're putting a trach in. So that's what she had to decide. Myself, I don't know. I'm not opposed to a trach. I've seen a lot of people do really well with trachs. End-stage lungers who working so hard to breathe they can't even eat, can't enjoy their favorite beer and pizza because they can't eat because they've got this mask on all the time. And then I've seen those guys get a trach. Suddenly they can eat, they can live life, they can breathe, they can sleep. It's not the worst thing in the world. I have it on my advanced directive. I have a very bizarre advanced directive I typed up for myself with the pandemic. I keep trying to explain to my family that I never want a peg tube, but I'm okay with a trach. I never want CPR. Don't be doing no chest compressions on me. They don't work. They just break ribs. It's all marketing. You can shock me with an AED just because it sounds fun, interesting. I have all this written on my advanced directives. Shock 3 times, no CPR. Trach, it's okay, no peg tube. We all, as nurses, you'll get very opinionated about those kinds of things. But our poor patients, they've never dealt with end of life things, and now especially it's her own end of life. What do you do? Kind of hard patient, sad, but. The anion gap that I was talking about, that story, again, I've only had to use this a couple of times in my career. And I mention that because the one patient that I've always lectured about, I used to teach what was called advanced cardiac life support for experienced providers. So I actually taught ER doctors and PAs and nurse practitioners how to deal with different types of overdose patients, because I'm the mental health guy, but I'm also the critical care guy. So kind of my combining of my two expertises, the overdose patient. And even then, I've only really seen the anion gap used a couple of times to where it made a difference in the care of the patient. So it's super confusing concept. If you're interested in it, do read this. I don't think there's any, there might be one exam question on anion gap. We do see an elevated anion gap in ketoacidosis. That's the most common. Those kids with diabetic ketoacidosis. Those ketones are causing a gap. Anyway, that's chapter 8. Again, don't spend a ton of time on it. Do know that there's 4 types of disturbances: respiratory and metabolic, and then either acidosis or alkalosis. Anyway, it's break time. Let's take a break, 10 minutes, and then we're going to dig into chapter 20, which is the lung stuff.